Okay, now let's generate the regular lift chart and decile wise lift chart. And for this we need the gains library. We already have gains library set up. So let's say we want to save the gains data in here, and we need to specify two columns of data for gains. One is the actual class and the second one is the probability. So it's very much like this ROC. So in fact I'll just copy paste these two under gains. Okay, so gains, the actual class and the probability that we have computed for that class. Okay, we run that and then we have the information here. It automatically figures out how many the depth you because this is most of the positive cases are okay. So once that is done, then we set up the two lines that we need. We need to set up the data. Then we have done this previously, so I'm going to repeat that. This is from chapter 5. So y is gain dot cumulative cumulative percent of total, right? And we multiply by the sum times sum of BH dot, okay, so here cat might be, so the sum of the target value. So that's 1 point, and then so it'll take each of the cumulative percentage total and multiply by that, and then x will be the cumulative observations. Cumulative observations. Okay, let's run these two. Okay, now remember these two do not start with 0, so we have to add the 0 to it. So y is c of 0 should go to the top, so 0 comma y. So the 0 will be added at the top of y. And then x is again c 0 comma x. So these two lines of code will set up the well, actually we need one more line, so that will be that xy dot data frame, and that is equal to data frame x and y, x comma y. So x and y will be used as the column names. So if you run these 4 lines of code, okay, xy is now ready. So there it is. And then second line is x equal to, so that's your baseline going from 0 0 to the end point. So the two values of x are 0 and n row of the validate set, and y is again starts with 0 and it is the sum of y, so the target. Cat might be. Alright, so now these two lines of code will set up the well, I need to put them in a data frame. So that is the base data frame. BDF is data frame x comma y. Now that code will set up the baseline. Okay, so now we can do the ggplot. ggplot, okay, data equal to null. Okay, we'll specify the data. The next one, mapping is AES, x equal to x and y equal to y. Okay, so now we do a geom line of data equal to xy.df, okay, and then plus geom line data equal to b.df. Okay, so then you get the lift chart. Okay. Now, remember, I'm just generating the chart and not spending time on setting up the labels, and we have done those labels many times. So when you do the work, you need to practice that. So I will be looking at not not just this. You need to add um, the labels and titles and everything that I'm not doing for want of time, but you need to take the time and finish it up. We have done this many times, so you already know how to do it, or you should know how to do it. Okay, and the decile wise would be a bar plot of, we take the gain dot lift, okay, and these are in percentage, so we need to divide by 100. Okay, and the names come from names.arg, the gain depth. Okay, and then okay, so just for now, let me add. So this is the base plotting procedure. So we have xlab equal to, right, percentile ylab equal to mean response. Okay, and then title, okay, so that's main equal to decile wise lift chart. Okay, I have some error here, so main. All right, so now we have the lift chart.